Hi, I'm Seth Rotenberger, and I'm going to show you how fast and easy it is to create organic shapes in NX using surfacing. This modeling tool enables the designer to create the desired shape by creating curves and sheet bodies that are combined into a solid body. Let's take a look at the process. In the graphics window, you can see I have an artistic sketch of a razor handle that I have imported into NX. I will use this as a reference to create my model. The first thing we need to do is create some sketch profiles of the razor. I'm going to use a spline to define the top and bottom profiles of the razor. I am selecting directly on the artistic image to generate the outline. The lines are extended past the reference sketch so that there is more material to work with later on. More points can be added or moved on the spline during the sketching process. You can see how easy it is to sketch a profile. I am now going to continue and create the bottom profile using the same technique. At any stage, the spline points can be moved to modify the shape. Now that I have created the top and bottom profiles, I am now going to generate the mid profile, which is the mold split line for the handle. The top and bottom profile and the split line are going to be created as separate features in the model. I am going to extrude the top and bottom profiles. As they do not form a closed boundary, they will be generated as sheet bodies. So I've generated the top and bottom profiles of the model. I am now going to look at making the side profiles. And as part of the process to ensure that we have a perpendicular transition across the center line, I'm going to create some reference geometry to let me do that. Similar to what we did for the top and bottom profiles, I am now going to sketch out the shape. When I select the endpoint of the vertical line, the software prompts me with the opportunity to control the transition. In this case, I'm going to use G2, which is a curvature continuation. You can see, as I change the position of the vertical line, the spline automatically updates. I only want these as reference lines so that they will not interact with the geometry later. I am now going to repeat the same process, but this time on the outside edge of the artistic image. As the part is symmetrical, it would be useful for me to see the other half. Rather than creating extra geometry, I can use mirror display to help me see the other half. We now have the shape. I am going to make some organic changes to the geometry. To do this, I'm going to use X-form to change the degree of the surface. And then I can drag the poles or polylines to make some subtle changes to the geometry. What would be useful is to get an idea of how the shape is morphing. And to do that, I will use some analysis tools such as reflection lines, which will allow us dynamic feedback of how the shape is evolving. As I am pulling this down, notice how the mirror display is updating so that both halves are symmetrical. You can see that there's a mismatch between the curves because it's not quite tangent across the center line. I can fix this by using edge symmetry. I'm going to change the movement so that the curve is normal to the symmetry plane. As you can see, the lines now have a nice smooth transition. The trim sheet command is useful for when a sheet body needs to be cut along a profile edge. Here, I am using the most center line to create the top part of the razor handle. The process is repeated again on the bottom of the razor to create the most accurate model possible. Toggling the Show Results button is excellent for making certain which part of the sheet body is removed. The command finder is helpful for finding commands that you may not normally use or that you don't currently have in your user interface. I'm going to project the split line curve and the outer profile in different directions, and the resulting 3D curve is what I'm going to use to continue my design. Now that I have my combined curve projection, I'm going to use that to define a law extension, which will generate a surface at a particular angle from a curve. In this case, I am using this normal vector because I want it to follow the z-axis. I've got my top and bottom surfaces and a law extension, which is going to help me control the shape as I transition from the top surface to the mold parting line. And to do this, I'm going to use Styled Blend. Styled Blend gives me a number of options for controlling the shape. I'm going to bring back the reflection lines to get a good idea of how the transition looks between the sheet bodies. The model doesn't quite match the artistic image, so I'm going to change the depth of the transition to fix this. I am now going to repeat the same process on the bottom half. Now that I have generated my top and bottom halves, I would like to actually create the other half of the model, as this is just a display. So I'm going to use mirror geometry to physically generate the other half across the center line. At the moment, these are all separate surfaces, and I would like a solid body, so I'm going to sew the existing surfaces together. The neck of the razor handle is not currently flush against the front plane. To fix this, an at distance plane is created along the handle, and the sheet body is trimmed along it. Finally, I need to close the gap that you can see here. I'm going to use the fill surface command to do that, which will not only create the surface, but also patch it into the body at the same time. You can see now that this part is a solid body. In order to create a recess for the razor connector in the razor handle, I can subtract a body that represents that. I keep the tool body so that it can be used downstream later. Now that we have our completed shape, we may want to perform some checks. And NX has a comprehensive set of tools to validate models. We can also check the moldability of the part by using draft analysis. It is always useful, as you are coming to the end of the design process, to visualize what the product will look like when manufactured. We can use the high-quality rendering inside of NX to do this. I'm applying a red plastic to the razor handle. I think a rubber material would look good on the sides of the razor handle, so I'll add that next using the face selector. You can see how many different materials there are to choose from. There will definitely be one that is suitable for your own application. Sandblasted aluminum is then added to the razor blade connector. After the materials have been selected, the usage of Ray Traced Studio allows for the rendering of the actual image. While this is rendering, let's recap what you have seen. You've seen me take reference images and use those to generate profiles that enabled me to construct surface geometry to create the razor handle. You saw a number of different techniques, as well as analysis tools that can check the moldability and also the surface quality of the part. And finally, once complete, we've looked at a realistic rendering of the model. I would like to thank you for your time and attention.